Well, hello friends. Today we are going to work a little bit on timers, and it's going to be about this thing that always annoys me in desktop systems, which is where you have something that's going on and then it's not on screen, but you still see that program using CPU. And we already spent some time working on memory usage of things that are not visible. Today I'd like to do something about wake-ups and timers. So this program here, the Fire program, it's just rendering off screen, and it's not actually doing the paint anymore because in a previous video then we stopped sending paint events to things that are either minimized or completely occluded. But what we're going to do is we're going to take it so that we don't even send timer events to this process. And the way that it currently works is that the process will just wake itself up every so often because it has a recurring timer in it. So we'll look at how that's like. So I think we're using start timer. So we start a timer here that wakes up every 20 milliseconds to do some logic. Note that it will call the timer event on this function. So there are a few different ways to do timers in the system, but one way that you can do it is if you're a C object or you inherit from C object in some way. So Fire inherits from G widget, which inherits from C object, which is the libcore, the base building block in libcore. Then you can start a timer, and then the event loop will call timer event on you every so many milliseconds. And that's the mechanism used here. So I think what we're going to want is we're going to want a way to say start timer like we're normally doing, but this is like a user interface timer or something like that. That basically to communicate that we don't care about getting this timer callback if we're not visible, because yeah. So maybe we'll just call this like start timer, and then we'll have it something here like UI timer mode UI or something like that. But it would be nice if this would be some totally automatic thing, so you didn't have to care about passing that. It would just figure it out for you. Maybe we can do that actually. Maybe because Fire is a widget, and that widget is in a window, and we could say that we don't send timer event to widgets that are not visible and not yeah, and then we could have a mode where you say start timer and I still want this event even though I'm not visible. So you would have to opt in to getting the event anyway. I think maybe that's actually a bit better. So let's try something like that. So we tweak the timer API here. Let's say should fire when invisible. Timer should fire when invisible. No will be the default. And then say enum class something like that. When invisible, or when not visible. Because invisible sounds a bit like it's another thing, not visible. Maybe this name is not perfect, but we'll go with it. I think it's okay. So the default behavior will be to not fire timers when not visible. And Then we're going to have to pass this information along to the event loop where we register the timer. So we'll say timer should fire when not visible. We'll just pass this along here, fire when not visible. And then we'll have to change this API, register timer. And okay. And I guess we store this event loop timer object. This is what we keep in the event loop to keep track of all the different timers that we are tracking. So we'll add a timer should fire when not visible. And we'll say, we'll just give it a default value. No. And then we'll set that fire when not visible. And then, so the way that we deal with these timers, because we have this, this is application global. So in the application, there's a hash map of timers currently, and it's a map of a timer ID integer that points to a event loop timer object, basically. And whenever we are setting up the main loop select call, because in Serenity GUI applications and anything that uses libcore, the main loop basically consists of a blocking call to select, which then listens for anything happening on any file descriptor that we're interested in. And it also has a timeout that's based on the all of the timers in the program, so that even if nothing happens on any of the file descriptors we're interested in, we still get a timeout so that we can fire our next timer. And if we look at here, for instance, what the Windows server is doing, if we just catch him at some random time, then you can see that he's blocked in a call to select, which is below the event loop wait for event here. So this is the main loop that every libcore program looks like this. So if you look at these different programs here, menu applet, system monitor is a bit goofy because it's the program that's currently running. But you can see taskbar here, for instance, also blocking and select. So the way that we set that select up is we have a call to select here somewhere in wait for event, as you just saw. And here is the call. We use this safe syscall helper to make sure that we retry until it works. But because you can get this interrupted syscall, and then we just want to restart it. So we're using this little mechanism here to do that. But basically, it's just a call to select. And the timeout, either we should wait forever. If we have no timers, then there's no need to have a timeout. But the timeout otherwise is computed here by walking all of the timers in the program and figuring out which one is the next timer that's going to fire. And this is, it's not terribly efficient at the moment. We just walk the whole timer list. And it's not sorted in any way. We could definitely optimize this with something like a timer heap, but it's just unoptimized at the moment. And it's been working out fine because we rarely have more than 1 or 2 timers anyway in a program. But what we want to do now is we want to take into account visibility, and it's specifically of the object that owns the timer. So let's look at that event loop timer thing again. So there's an owner, weak pointer to an owner, and then we have a fire when not visible thingy. So I think what we're going to do now is we're going to see if we can somehow get from the owner to a window And if we can get from an owner to a window, then we can check if that window is like either minimized or occluded, and if so, we can skip the timer. So let's see where we would do that. So get next timer expiration, right? So here's where we actually iterate over all the timers. And we should just skip over here if some timer is supposed to fire only when visible and it's not visible. So if IT value fire when not visible is timer should fire when not visible. No, then if IT value owner and IT value owner right, so now we are in libcore here. So libcore sits below libgui, and libgui is implemented on top of libcore, so everything in libgui is inheriting from C-object. But that means that in libcore, we can't ask questions about GUI stuff because none of that is visible to us. So what we can do is we can add a virtual function to C-object to be able to ask it if it's visible, basically. Is visible for timer, something like that. Timer purposes, or I think we'll do something like that. Is visible for timer purposes, and if that returns no, then we will continue to skip to the next timer. So maybe we can do it this way, actually. So, and that, and that. Wait, that didn't turn out good. There we go. It's really kind of awkward. All right, that's probably okay. Now let's add that thing to C-object. Let's say virtual pool is visible for timer purposes. And I think we can even take a batch C event loop here. I think, or where were we? Yeah, because nobody else should be calling this API, so we'll use a batch for that. And we need to forward declare. And I think by default, this can be const, and by default we will return true. It is visible for time purposes. This is probably not the best. This is not the best name. I don't love it, but nothing else really comes to mind at the moment. So let's see. Then we will make a private variant of this. Here we'll just override this right quick. Override. And what we'll do is dwidget. Oh, const. If, let's say auto window is this window. If we don't have a window, no. Otherwise, return window is visible. Can we ask that? Oh, but this is not the best information. So in GWindow, we have this. We get notified when the state changes. We get told if we're minimized and if we're occluded. Occluded just means that we are covered entirely by one or more opaque other windows, so that no pixel in this particular window can be seen by the user right now. So we could probably also just remember this. Or we can also say visible for timer purposes. We can do this. Not minimized. And not occluded. That's probably okay. Let's say true by default. And then we'll have a bool visible for timer purposes. And maybe we'll only let GWidget ask about that. Okay. Pass an end badge and see event loop. To pass a badge here as well. Okay, so now by default, all timers will be not fired if they are owned by a widget that has a window that's currently not visible or not unmaximized or unminimized. I think I said that correctly. There was a lot of Boolean in that statement. A lot of Boolean business. So let's see. Oh, failed to compile. What have we done? GWidget. This is private in this context. Well, it's my bad. Wait, was it? What class am I even looking at here? Who's private? GWidget CPP 706. What? Oh, wait, hold on. It's visible for timer purposes. I can't. Oh, this is selecting the C object thing, but I wanted to have the same thing on GWindow. That's not good. Oh, and it actually had a different name here, so we'll call it window is visible. That got a bit confusing. Now, this mechanism, I think it's pretty sane, but it's not going to work in situations where you create a C timer, for example. Very often we do C timer construct, and those are not going to have a GWidget owner. Instead, they are owned by CTimer, which is CTimer is just a convenience class in C object that implements the timer event function itself, and then you can create as many C timers as you like, and they all individually set up these timers. So in those cases, there's because they're not GWidgets, then they don't know how to get to their GWindow if there is one. But they are still C objects, so they still participate in the C object hierarchy. And for example, we can see here that the process memory map widget in the system monitor, it creates a C timer here to wake itself up every 1,000 milliseconds. So once per second, wakes up and calls refresh. And it passes in this as the parent pointer to the C timer. So the C object model is that there's reference counting, and that also everything is in a tree where your parent owns you. So your parent will always keep you alive. And this is how the widget tree is constructed, for example. And now it also gives us the ability to go from any C object and just walk the parent chain and see if we find a G window. So let me check if C object has any knowledge of windows. Yes, it knows is window, which I presume is overridden here by G window. Right, so we can ask a C object if it is a window, which actually means that we didn't need to do this in the virtual way like that. So let's not do it that way. Let's instead say maybe we can let it be like that actually. But I was just thinking we could walk the parent chain to find the window. But I wonder if that would work for main widgets. G window set main widget. The main widget is always a child of the window. Okay, then actually we can do it that way. Then this part right here, we can do in C object instead. So C object, visible for timer purposes. We'll just say this is non-virtual. And instead, we will just walk the parent chain. So ancestor is, well, let's see, if is window. Oh, well, no, we can't do it that way, but we can make this virtual and override this on window instead, and then we'll just traverse the parents, right? So, like that. And here, if I'm a window, then I already did the right thing. Otherwise, I will just say if parent. If parent return parent is visible for timer purposes. Otherwise, return false. Can we pass this along? I think we could. No, we can't. Well, that's limitation of the badge mechanism. Well, we're gonna have to live without the badge at this moment. That's okay. The badge wouldn't really be doing its job if you could just forward the badge to someone else. The purpose of the badge is to ensure that only someone from this class can call this function. But we'll do okay with that. So now when you call this, we will check if we have a parent, then we'll ask the parent, are you visible for timer purposes? Otherwise, we'll just return false. But since it's virtual, if any of our parents or us are a window, then we will return this flag. And here, when we figure out when the next timer is going to expire, then we will ignore any timer that should not fire when not visible. If its owner is currently not visible for timer purposes. I think that's good. Come on, libgui. Build faster. Because I really want this mechanism to be as automatic as possible. Because this is the kind of thing where if you make it opt-in, then it's so easy to forget to opt-in, right? And I think it's much better if we make it so that if you actually want a timer that gets woken up, even though you're not visible, even though you can't show the user anything in the current window, then you have to specify that you want that. Because you just see so much software these days that's just sitting there, you know, idling at a couple of percent CPU, and that's really silly. And I know that something that frustrates a lot of people is like they have these editors that are built on this web application stacks, and they're just sitting there in the background chewing up CPU, just blinking their cursors, and that's very silly. So let's not get ourselves into a situation like that, and like let's be proactive here and make the system very calm by default, or serene, if you will, because I think that's appropriate. Not just for the name, it's just appropriate in general to sit still. You know, if the user is not even looking at you, just don't do anything. Unless you're like a network program downloading stuff or whatever, but even then, there should be some limitations and some sanity. Although that's kind of a different, I guess, a different angle of this thing, where I also think that if you are a program that downloads something from the network, unless the user is currently interacting with you, then maybe it's not urgent that you finish that download. Has to be, you have to differentiate between things that are not urgent and things that are. Well, it'll be a lot of fun stuff that we get to work on as we continue down this interesting path, but one thing at a time. Easy does it. Okay, so can we get that fire guy up on screen here? And we'll just cover him, and notice that he plops down to a comfortable 0 CPU. There are no syscalls happening. And if we uncover him a little bit, oof, he starts working. But as long as he's completely obscured, or occluded rather, it will do nothing. That's really sweet. And of course, the beautiful part about this is that we made absolutely no changes to the Fire program, and I think that's the way it should be. This should be the default behavior. So, what else is something like this? If we take a program like, well, probably File Manager does something, or actually it doesn't do much. What's something that will update in the background? How about the snake? Definitely paints in the background. Oh, do we have a rendering glitch there? Oh, it seems like we do. It's probably something that we need to work on. But now he was about here, and if I go back, it's still there. So if I interrupt, he's like just on the left of the middle. Yeah, this is kind of strange behavior, right? You kind of expect the game to keep going in the background, but at the same time, do you? I'm not sure. I guess probably we do. Let's say that we expect Snake to keep going. Although I'd rather like the idea of Snake not going in the background. Are you doing anything right now? He's not doing anything. Maybe we should not do anything when he's in the background. Oh, why is that so slow there? Okay, that's kind of cool. What else can we do? I guess we have the widget gallery. Oh, this one doesn't paint at all. Wait, what's going on here? Something is not right. This one only updates when I move the cursor. Also, this looks wrong here. It's supposed to be white. It's supposed to be white on top. Okay, we have to fix that. Style painter, first of all. Let's fix that white issue. Paint progress bar using the base text, and we draw the text a third time, clip then inverse for shot contrast. Draw text. Do we have a way to invert colors? Inverted. Oh, look at that. Well, I guess that'll do the trick. So base text inverted. But why were we not getting those timer events? That's pretty weird. So how does widget gallery work? We make a C timer, and it has no parent. So this is an C timer with no parent. Oh shit, right. So in C object, we say, are you visible for timer purposes? If we don't have a parent that's a window, we should just say, yes, you are visible for timer purposes. So this will only apply to widgets or timers that are in some kind of window hierarchy, because otherwise we can't know. I mean, you could imagine being more aggressive and then having like on the application level, you could track a flag like, are any of the windows of this application visible versus just a single window. But I think for today we are just going to focus on the timer within the logical window hierarchy purpose of this. All right, so here we go. Now if we bring up the widget gallery, now this looks totally not right. So I guess I was changing the wrong paint call. Style painter. So this was evidently black already, and here's where we're drawing black on top of base text. That's the problem. We need to be drawing palette base text inverted. But we did have the timer kept going this time, right? I got some of these color bugs still coming out because we're still being found. Because I was changing up a lot about how colors work in the system to get theming to work. So then there are like there's little mistakes here and there that I'm still finding, like this progress bar rendering. It seems like maybe I don't see progress bars that often. Maybe we should put more progress bars in the system. So bring this guy back up and look at that. Will it be white on black now? No, they're backwards. Dang it. All right. We'll just swap these guys. But the timer stuff was working, so what do we have here? Let's do the progress bar fix first. Text rendering, text paint, and rendering in progress bars. And then the way this works now is when GWindow gets notified that his state has changed, you will update a member bool called visible for timer purposes. And we're considered visible for timer purposes if we are not minimized and not occluded. And then when we start a timer, I don't know why this is this way, by the way. I guess it is. When we start a timer, then we have to pass in a timer should fire when not visible flag, which defaults to no. And that is then passed along to the event loop when we register the timer with that flag. And then the event loop uses that flag to check if the owner of the timer is currently visible for timer purposes. All right. I think that this is really good. So what does system monitor do if we close them up like this? It's just top running now, right? System monitor is doing a little bit of stuff. It doesn't actually update until we open it back up. I think that's fair. So I don't really care what system monitor thinks unless I'm opening him. Now when it comes to stuff like this graph though, it's a bit weird if it doesn't update. System monitor. Oh, actually it was collecting the data points, just not updating the GUI. That's perfect. That's exactly what we want. So let's see why it's like that. That will be in system monitor main. Do we have some timer? Probably in system monitor graph widget. Where do we add values to this thing? In the memory stats widget, what? On new CPU data point, okay? Which is called by the process model when it updates, which is called by who's calling that? Okay, let's just find out who's calling it, because I don't remember. Process table view. Update. In refresh, which is called by who? Oh, right here. It's a C timer, system monitor main. And it's a C timer that has no parent. So if we were to pass a parent here, like a window, do we have a window here? Maybe we haven't made a window yet. Well, we could pass in one of our widgets. If we do this though, then the graphs and stuff will no longer update when the window is not visible. So I think we should leave this alone for now, but it's something where we can definitely improve because we want to update the graphs, but not the UI. And we don't want to paint the graph, we just want to update the data. Anyways, I think we have something good here. So let's say libcore plus libgui. Don't fire timers in non-visible windows by default. Let's see, libcore timers now have a should fire timer. What was it called? Timer should fire when not visible. Yeah. Flag default, which is default set to no by default. When considering timers, when the if no, the timer will not be considered. Will not be. Will not be. Oh wait. Should fire when not visible. Hold on. When not. I just realized something. That this is just for selecting the next fire time, but we also need to not actually not fire it just because something else fires. So if something else wakes us up, we're still going to fire timers at the moment. Which will be here. So after the call to select, we check if we have any timers, then we're going to start measuring timer stuff. So we iterate the timers and check, has this timer expired? If so, we're going to fire it. But here we're going to say if, I guess we can check that easily, but then we can say if timer fire when not visible. I mean, that whole thing that we had down there, we need this again. So like that. We're just going to skip over this timer. So even if something else wakes it up, then we don't fire the timer anyway. Yeah, that's the correct thing to do, and then that means that we'll do even less stuff. Hopefully. If no, the timer will not be woken up, will not be fired by the event loop when will not be fired by the event loop if it's within a C object tree whose nearest G window ancestor is currently not visible, not visible for timer purposes. Specifically, this means that the window is both, either minimized or occluded. And so does not benefit from timer fires that would only update the UI. Does not want to fire timers, just to update the UI. This may expose some issues But this is another nice step towards a calm and serene operating system that doesn't, no, just that. Okay, and just make sure we get all those changes, and then we'll do a build again with this, and then we gotta look at that snake bug, but I don't think that's related to this. It's gonna be something else. It's probably was relying on those paint events for some reason. Okay, so bring me system monitor, and then let's cover him up and run top instead. Oh, do top here. SM right here. Very, very not busy. It's pretty cool. If he's on screen, how busy is he? Yeah, he's more busy. This is very neat. Let's try out the fire demo once again. So we got fire up here. 8% CPU or so when on screen. When occluded, 0. Love it. Do this. Starts painting, starts doing stuff automatically. Do this, totally stops. No source code changes to the program. I think this is exactly what we want. So who else is running right now? It's got Windows Server. We got the clock applet up here. It's hard to argue with him because he has to update every second. And of course, the audio applet doesn't do anything, but the CPU graph updates every second as well. But everyone else is sitting still in the boat. Very, very nice. And I guess we can try the piano app here real quick. See, piano is starting to chew up some CPU right away, but what if we cover him? It's not perfect. Still got that secondary thread generating sound. But you can see that the CPU usage is definitely higher when visible. So that's pretty cool. We'll just shut that down. And oh, I don't know why I'm multi-selecting now. Anyways, I think that's going to be it for today's video. So some pretty nice stuff here. I want to say thank you for watching, for hanging out while I work on the Serenity of the Serenity operating system. This is definitely an improvement in that area. So I hope you saw something interesting here today. And if you are currently making software that does annoying stuff, even though it's not visible, then maybe think about ways to stop doing that. But here, since we control the whole stack, I definitely intend to take a whole stack approach to like Serenity in the system, and just making it difficult, or like making it a manual step if you actually do want to be woken up in spite of not being visible. So yeah, I hope this was interesting, and I hope you're having a good post-Christmas holiday, and I guess I will see you next time. Bye.